Hello. Today, the members of Group 5 is going to do a presentation on the topic evolution of stars or stellar evolution. I am Anjali. I will give you a brief explanation on the topic evolution of stars. The subtopics will be elaborated by my teammates. Like any other animate object in the universe, a star is born, lives for a certain time, and then finally dies. Stellar evolution is a process by which a star undergoes a sequence of radical changes during its lifetime. Depending on the mass of the star, its lifetime ranges from only a few million years for the most massive to trillions of years for the least massive, which is considerably longer than the age of the universe. During stellar evolution, the following stages are expected to follow. All these stages will be further explained briefly in the upcoming slides. The stages are Protostar, pre-main sequence stage, and main sequence stage. During the final stage, the star may undergo a nova or a supernova explosion to become a red giant. Depending upon the mass of the star, it may end up with white dwarfs or neutron star or a black hole. Now Anupama will explain birth of a star.
Hello, I am Anupama here to speak about birth of stars. We all know stars are born when large gaseous clouds collapse under gravity. What is the birth of star called? Most stars are born inside the great clouds of gases and dust called nebulas. The process begins when the nebula starts to shrink, then divides into smaller and slim clumps. Around 90% of the star's life is spent in the main sequence phase, the middle age of a star. A star is born when atoms of the light elements are squeezed under enough pressure for their nuclei to undergo fusion. All stars are the result of the balance of forces. The force of gravity compresses atom in interstellar gas until the fusion reaction begins. Is Stardew Birth. Like pupil stars are born, they grow old and they die. The birthplaces are huge cold clouds of the gases and dust, known as nebulas. The most famous of this Orion Nebula, which is just visible in the unaided eye. Stars are born within the clouds of the dust and scattered throughout the most galaxies. A familiar example of such as the dust clouds is Orion Nebula, and turbulent deep within these clouds gave rise to not with sufficient mass that the gas and the dust can begin to collapse its own gravitational attraction. Stars are born in vast, slowly rotating clouds, so called gases and dust called nebulae. These large clouds are enormous and they have masses somewhere between 10,000 and 2 million times the mass of the Sun, and their diameter range from 50 to 300 light year across us. At what point is a star born? When the core of Protostar has reached about 10 million Kelvin pressure within is so great that nuclear fusion of the hydrogen begins and a star born. When we look at the clear night sky, we can see the gas clusters here and there, each containing mostly of hydrogen around 73% and remaining others such as N2, O2 and CO2. If by accidentally some denser parts of the gas clusters occur, then the gas particles surrounding it are begins to attract towards the denser parts due to the gravitational force. Through the millions of years, millions and millions of hydrogen atoms and other accumulated over the region, hence forms a sphere of gases. Steps for the evolution of a star. Stars come in varieties of masses, and the mass determine how radiantly the star will shine and how it dies. Massive stars are transformed into supernova, neutron stars and black holes, while average stars like the sun and life is white dwarf surrounded by disappearing planetary nebula. All stars are irrespective of their size follow the same seven stages of cycle. They start from the gas clouds and end up with a super remnant. Stars comes into varieties of masses and the mass determine how radiantly stars will shine. And gravitational contraction within a cloud of gas and dust. Rise in the interior temperature and pressure of nuclear fusion. Jane does a cloud. A star originated from a large cloud of gases. The temperature in the cloud is low enough for the synthesis of molecules. The Orion cloud complex in the Orion system is an example of a stars in the stage of life. A famous example of one of these huge clouds is Orion Nebula. In the constellation of Orion, it is visible with the naked eye if the sky is dark enough. These clouds are so massive that they are collapsed under their own gravity if they are disturbed. The collapse of the stars can trigger when the cloud is used. For example, if a cloud passes through a spiral arm in a galaxy, it will be slowed down and compressed. This explains why lot of stars are formed in the spiral arms of galaxies. Thank you.
Now, let's talk about the protostar. When the gas particles in the molecular cloud run into each other, heat energy is produced. This results in the formation of a warm clump of molecules, known as the protostar. These protostars are warm. They can only be seen through infrared vision. This can be differentiated from other materials in the cloud. Several protostars can be formed in one cloud, depending on the size of the molecular cloud. Now, let's move on to the Tauri star. Tauri star begins when materials stop falling into the protostar, and they release a tremendous amount of energy. The mean temperature at the Tauri star isn't enough to support the nuclear fusion at its core. The Tauri star lasts about 100 million years. After this, the main sequence of the star begins.
This is Bella and I am talking about young stars. There are two types of atomic reaction in a star. First one is when the mass of a star is less than or equal to the mass of the sun, PP chain reaction takes place. That is, two protons join together to form helium. The mass lost in this reaction is released in the form of energy. When the mass is 3 times the solar mass, energy is supplied from carbon-hydrogen cycle. Here, carbon acts as a catalyst, thereby two protons combine to form helium. When the mass is between 1 molar and 3 molar, two processes occur simultaneously. At the center, PP reaction, and at the outer, carbon-hydrogen cycle. So we can say that a star becomes stable for a long time without expansion or contraction. The heat released in this reaction, which is like a controlled hydrogen bomb explosion, makes the star shine. This additional heat also increases the pressure of the gas until it is sufficient to balance the gravitational attraction and the gas stops contracting. Such a star is called a young star. That is, for a young star, there is perfect balance between the gravitational pull inward and the radiation pressure acting outward. Then the star is said to be in hydrostatic equilibrium. When this stage is reached, the star is said to have reached in the main sequence. The perfect balance between gravitational pressure and the radiation pressure is like a balloon. There is a perfect balance between the pressure inside the balloon, which makes the balloon expand, and the tension in the rubber, which is trying to make it contract. Stars will remain stable like this for a long time with the heat from nuclear reactions balancing the gravitational attractions. Eventually, however, the gas will run out of its nuclear fuel. Paradoxically, the more fuel a star starts off, the sooner it runs out. In other words, luminosity of the star depends upon the mass of the prototype star. That is, the more massive the star is, the hotter it needs to be to balance the gravitational attraction. Whatever the lifespan of a star is, its 90% life will be in the main sequence. Remaining 10% will be in the states of red giant, supernova, white dwarf stages, etc. Next is the main sequence phase. The main sequence phase is the stage in development where the core temperature reaches the point for the fusion to commence. In this process, the protons of hydrogen are converted into atoms of helium. This reaction is exothermic. It gives off more heat than it requires, and so the core of a main sequence star releases a tremendous amount of energy.
Red giant. Red giant are a state of stellar evolution beyond the main sequence of life of star. After billions of years of core nuclear fusion reaction, the hydrogen supply and core of main sequence star is exhausted. When star exhausts this hydrogen in its core, fusion stops and the star no longer generates an outward pressure to counteract the inward pressure pulling it together. Now the core is regenerate ionized helium surrounded by the shell of hydrogen, fusion that continues the life of star and cause outer atmosphere to increase the size dramatically. The aging star has become the red giant star and can be 100 times larger than it was in its main sequence phase. The hydrogen fusion shell eats through the surrounding atmosphere and deposits helium onto the stringing core. The ballooning atmosphere cools down to around 3000 Kelvin and stars takes a red appearance. Hence the name red giant. In about 5 to 6 billion years, the sun will eat all the inner parts of our solar system and will reach the Earth orbit, thus entering the red giant phase. Final phase. Massive stars transform into supernova, neutron star and black holes. Less massive stars don't explode, their cores contract instead into a tiny hot star known as the white dwarf, while the outer material drifts away. Stars finer than the sun don't have enough mass to burn with anything but a red glow during their main sequence. These red dwarfs are difficult to spot, but these may be the most common that can burn for trillion of years. Here we conclude our topic evolution of star. Evolution of star or stellar evolution is a process by which a star changes over the course of time. We had included the birth of stars, step of evolution of star, protostar, young star, red giant, and a final phase in our topic. We had covered the life cycle of star in short. Thank you all for your great attention upon us. We hope all of you can understood what we teach. Thank you, Paisa, for this great opportunity and all our group members for your great effort. Thank you.